Okay, so we will continue this. So we have seen that we have to find out this M and T, that is a torque and a moment. So let us find out this torque acting on these two pulleys, that is on the pulley A and B, and also this vertical force TA1, TA2, and horizontal forces TB1 and TB2. So let us find all these values. So first we will see this torque and tension acting on this pulley A. Now we know this fundamental equation, that is T1 by T2 is equal to e raised to mu theta. This is a fundamental equation for finding the tension acting on a pulley. I will write it as equation number 1. So I will take this equation and write it for our pulley A. So I can write it as TA1, that is the tension acting on the tight side of the pulley A. TA2 is equal to e raised to mu theta. So mu it is given as 0.24, that is given in the question, and theta, angle of contact, it is given as 180 degree, that is pi radian. So I can write this as e raised to 0.24 into pi. So this I will get it as 2.125. Now the tension acting on the tight side is also given. It is given as 2.25 kilonewton. So TA1 it is given as 2.25 kilonewton. So substituting this value, this equation will become 2250, that is kilo 10 raised to 3 substitution, divided by TA2, that is equal to 2.125. So from this I can calculate this value, TA2, tension acting on the slack side of the pulley A, that is equal to, I'll get it as 1058.6 Newton. This is the tension acting on the slack side of the pulley A. So we have the tension on the tight and the slack side. Now the torque acting on the pulley, torque equation, torque on the pulley A, we know the fundamental equation, TA, that is a torque on the pulley, not the tension, it is a torque, that is equal to tension on the tight side minus tension on the slack side of the pulley A into radius of the pulley. So this is a fundamental equation. So here both the tensions we know this, 2250 minus 1058.6 into the radius of the pulley. The diameter of the pulley is given as 600 millimeter. So I can write it as 600 by 2. That is the radius of the pulley. So when I calculate this, I'll get this value as 357,420 Newton millimeter. That means it is 357.42 Newton meter. So this is a torque acting on the pulley A. Now we have to find out the torque acting on the pulley B. So I'll write it here. It is a torque acting on the pulley B, that is TB. But in the question it is given that the torque on the pulley A and the torque on the pulley B, it is same. So we have calculated the value of torque acting on the pulley as 357.42 Newton meter. Therefore, that value will be acting on the pulley B also. So it is 357.42 Newton meter. So we have the torque acting on the pulley. Now the remaining is we have to calculate the tension on the pulley. Tension TB1 and TB2. This we have to calculate. So again I will take this equation number 1. So when I apply this for the pulley B, I can write it as TB1 by TB2, that is equal to E raised to mu theta. We know this value for mu, it is given as 0.24, and the angle of contact it is given as 180 degree, that is 5 radians. So I can substitute this value and this will be 2.125. So from this I can write this as TB1 is equal to 2.125 into TB2. I'll put it as equation number 3. So we have this equation TB1 is equal to 2.125 into TB2. Now we have to take this torque equation. So when I take this fundamental torque equation and apply it for this pulley B, I can write this torque on the pulley B, torque acting on the pulley B, can be written as TB1 minus TB2 into radius of the pulley B. So here I can substitute this value of TB1, that is equal to 2.125 into TB2 from this equation 3 into this equation, and I can find out this value. So if I write that value, it will be TB is equal to 2.125 TB2 minus TB2 into the radius of the pulley. The diameter of the pulley is given as 400. So that means radius is equal to 400 by 2. And so this will be equal to TB, already we know, that is 357.42 Newton meter, that is equal to 2.125 minus 1 into TB2 into 200. So I can do this calculation now. This is 200. So when I do this calculation, the value of TB2 the tension acting on the slack side of the pulley B, I'll get it as 1588.53 Newton. So the tension acting on the slack side of the pulley we are having now. This value we can substitute in this equation number 3. So substituting this value of TB2 in the equation 3, we can find out TB1 is equal to 2.125 into 1588.53. So that is equal to, I'll get this value as 3375.63 Newton. So this is the tension acting on the pulley B on the tight side. Now, the total vertical force acting on the pulley A, vertical load on pulley A equal to TA1 plus TA2, that is equal to 2250 plus 1058.6. So the answer is 3308.6 Newton. This is a vertical force acting on the pulley A. And we know there is no horizontal force acting on the pulley A, but we have a horizontal force acting on the pulley B. So the total horizontal force or load acting on pulley B is equal to TB1 plus TB2. So we have this value for TB1, that is 3375.63, plus TB2 we have 1588.53. So the answer is equal to 4964.13 Newton. So this is a horizontal force acting, and this is a vertical load on the pulley A, vertical load, and this is a horizontal load on the pulley B. This is very important. So we have the horizontal force as 3308.6 and the vertical force as 4. The horizontal force as 4964.13 Newton and the vertical load as 3308.6. So we have calculated the torque acting on both the pulleys and the tension acting on both the pulleys, and also the total vertical load acting on the pulley A and the total horizontal load acting on the pulley B.